Shri Swami Samartha. So our today's topic is the polymer. So we all are the familiar with word polymer, right? So the polymer are the high molecular weight macromolecule and it consisting the repeating unit of the monomers. Okay. So the multiple or large number of monomers they combine together through the chemical bond and they forming the polymer. So we know the polymers can be occur naturally as well as the synthetically that we have to study in detail. And the polymerization process. So we know the process in which the large number of monomers they combine together and they forming the polymer. That process is called as the polymerization process. So now we are study the classification of the polymer. So now we are study the classification of the polymer. So polymer are basically classified into the mainly 5 classes. Okay. So based on their sources, they are classified as the natural polymer, semi-synthetic polymer and synthetic polymer. And next is the based on their structure, they are classified as the linear polymer, then branch polymer and network or cross-link polymer. Okay. And third, that is the based on their molecular forces, they are classified as the elastomers, fibrous, then thermoplastic polymer and thermosetting polymer. So we all are the familiar with the thermoplastic and thermosetting. Then also we are studying in detail. Then based on their mode of forming, they are classified as the addition polymer and condensation polymer. Means in which we have to study the addition polymerization reaction and condensation polymerization reaction. And the fifth one, that is the last, that is the growth polymer, that is also classified as the addition polymer and the condensation polymer. So each one we have to study in detail. Right. So based on their sources, the polymer is classified as the natural polymer, semi-synthetic polymer and synthetic polymer. Okay. So we have to study the each one by one. So first is the natural polymer. So we know that those polymer is obtained from the nature. Means those polymer is obtained from the plant as well as from the animal. So those polymer are called as the natural polymer. Okay. So for example is the cellulose and rubber. We know the paper which is also made up of the cellulose. So that is also example of the polymer. Then rubber which is also obtained from the nature, from the plant. So that is called as the natural polymer. Then semi-synthetic polymer. Semi-synthetic means it is a combination of the natural and the synthetic. Means the properties of the natural polymer that modified with the chemical treatment, which gives us the semi-synthetic polymer. Means for example is the Rayon fiber, that is also is the example of the semi-synthetic. Then next is we know the cupra ammonium silk. It is a type of the silk which is made up of the cupra ammonium, mixture of the copper and the ammonium. So that is called as the semi-synthetic polymer. And last one is the synthetic, means those polymer which is obtained from the complete chemical substance, that is called as the synthetic polymer. Means for example nylon and terylene. So we know the nylon fiber, terylene fiber, then polythene which is also the example of the synthetic polymer. I hope you all understood this base classification based on the sources. Right. Next is the based on their structure. So based on the structure of polymerization, they are classified as the linear polymer, branch polymer and a network cross-link polymer. So first is the linear polymer. Linear polymer is the polymer which is contain the long continuous chain of the monomer. Now we have to take example of the linear polymer. So here we have to write the ethene. So we know the molecular formula of the ethene, that is a CH2 double bond CH2. Okay. So it is a ethene. So ethene is used as the monomer, which is undergoes the polymerization reaction. So if we do the polymerization of some compound, then which is first forming the repeating unit. We know the polymer means it is a repeating unit of the monomer. So here we have to write first repeating unit. So we have to simply convert the double bond into the single bond. That is a CH2, CH2. We have to write this. So this is the repeating unit of ethene, and finally we have to write that is a CH2, CH2 single bond, and here we have to write bracket, and here is the end time. Means the number of time this monomer repeating unit is continuous with longest chain, and they forming the linear polymer. Okay, so this polymer is called as the polythene. Okay, another example that we have to study, that is the PVC. First we have to write the vinyl chloride molecule which is undergoes the polymerization reaction, and we have to get the PVC, that is the polyvinyl chloride, which is also the linear polymer. So here first we have to write the vinyl chloride structure, that is the vinyl chloride monomer we have to use. So simply it is the CH2 double bond CH, one hydrogen atom in ethene which is replaced with the chlorine. Okay, so that is the vinyl chloride, which is same undergoes the polymerization reaction. Then we have to get the repeating unit of the vinyl chloride, that is the CH2 CHCl. So it is not a branch. Okay, so it is a, we have to only write here or here, so we have to adjust here. So it is not a branch, so it is a repeating unit of vinyl chloride. Then finally we have to get, that is the PVC, that is a CH2 CHCl, and here we have to write the bracket and N, that is the PVC, that is the polyvinyl chloride. Okay, so these two are the example of the linear polymer. So the linear polymer which is having the high molecular weight and high melting point, high density. Okay, as compared to branch which is having the lower melting point and lower tensile strength also, and lower density also. Okay, so now we have to study the branch polymer. So in which we have to take the example of the propylene. So first we have to write the structure of propylene, that is a CH3. We know the propene means it is a 3 carbon atom. So propylene means here we have to write the double bond, and we have to satisfy the carbon valency. Okay, so it is a propylene. Okay, so now it is converted into the branch polymer, that is the polypropylene. So it undergoes the polymerization reaction. Then we have to get the repeat to convert the branch. So this CH3 is attached with carbon. So we have to write here. Okay. So branch polymer is obtained. That is the CH, as it is single bond, it is a CH2, and that CH3 we have to attach here. Okay, so we have to get the branch and write in the bracket, that is the n number of time. Then it is the repeating unit, and finally we have to get that is the polypropylene. Okay, so this is the example of the branch polymer having the lower molecular weight, lower melting point and lower density. Okay, so the last one is the network cross-link polymer. So the polymer which is having the long chain and linking with the strong covalent bond and they forming the network like zigzag-like structure or cross-link structure. So those polymer which is including in the cross-link. So example is the melamine and second is the vulcanized rubber. So vulcanized rubber is the common. In exam they have to ask you for 3-4 marks. Write the detailed structure and the detailed process of the vulcanization of the rubber. So here we have to study the example of the vulcanized rubber. So we have to take the cis-1,4 isoprene molecule that is undergoes we have to treat it with the sulfur and we get the final vulcanized rubber. Okay. So first here we write the structure of cis-1,4 isoprene. So first we have to draw one by one. So this is 1,4 isoprene which is we have to treat it with the sulfur. Okay. So we have to get the vulcanized rubber. So here is forming the disulfide bond. Similarly here also form the disulfide bond. And this structure is the continuous and forming the cross-link network. Okay. First we have to draw the parent structure as it is. Then we have to show the bonding. Here is the parent structure, then this bond as it is we have to show, then this two bond as it is we have to show, right? And here is the forming this disulfide linkage, that is the SS, and here also we have to form the disulfide link in this upper bond as it is, and here is the continuous structure with the another molecule. Okay, so this is the vulcanized rubber. Okay, so I hope you all understood this network cross-link polymer. So if you like the video, please go on YouTube and like, share and subscribe the Kemguru YouTube channel. Thank you.